I'm going to do a numerical example, which is in the book about the copper industry. So you would have you would know how to calculate the equilibrium price and equilibrium quantity for the example at the beginning of the chapter about the copper industry. Let's assume demand for copper is a function of variables such as the price of copper, such as income level or income index, such as telecommunication variable as an index of whether they would substitute something for something else, depending on the price in the telecommunication, depending on the price of copper versus, let's say, aluminum. And also another variable called the expectation of future prices. You have had statistics before, so you know how to do a regression of, let's say in this case, we have 4 independent variables and 1 dependent variable. So we are saying quantity demanded for copper depends on price of copper, depends on income, depends on telecommunication index, depends on expectation index. So the way we would do it is we collect data for all these 5 variables, and then feed it into the computer. You can use Excel, you can use SPSS, any statistical program, and do a simple multiple regression. So you collect data for a year, monthly data, weekly data, for a year or two, and feed it to a computer, and that would give you the coefficients of each one of these variables. Let's assume we did that, and we came up with this function. Quantity demanded for copper is equal to, this is in your book by the way, 3 minus 2 PC plus 0.2 I plus 1.6 TC plus 0.04 E. Now, these coefficients which is calculated by the statistical package, in this case, minus 2 for price of copper, 0.2 with the plus sign for income, 1.6 for telecommunication industry, and 0.04 for expectation, shows the relationship, the strength of the relationship between each one of these independent variables, this one, this one, this one, and this one, with the quantity demanded. So, for example, the negative relationship between price of copper and quantity demanded shows that when the price of copper goes up, the quantity demanded will go down. For every 1 unit, in this case, for every 1 unit increase in price of copper, quantity demanded will go down by 2, the negative 2, therefore, in this case. All right. Now, since we want to draw this on a 2-dimensional plane, we only need 2 variables. And the 2 variables we're going to work with would be quantity demanded and the price. So we have to assume all the other variables are constant. So those other variables would be given to you. For example, income would be equal to 20. Telecommunication index would be equal to 2.5. Expectation would be equal to 100. So if we go ahead and plug in these numbers into the equation above, then QD would be equal to 3 minus 2 times PC. We have to keep this the way. Now in place of I here, 0.2, in place of I we put the constant of 20. 1.6 for telecommunication we put 2.5. And plus 0.04 times expectation. For expectation we put 100. Therefore QD would be equal to 3 minus 2 PC plus 0.2 times 20 is 4 plus 1.6 times 2.5 is also 4, and 0.04 times 100 is also 4. Therefore, QD equals 4 plus 4 is 8, plus 4 is 12, plus 3 is 15, minus 2 PC. So what we have here now is quantity demanded as a function of only one variable, and that is price of copper. So quantity demanded for copper is only a function of price of copper, because we assume all the other variables, income, telecommunication index, and expectation index, all of those remain constant at the given value. By the way, if we want to graph this function, since in our functional relationship we always put quantity on the horizontal axis and price on the vertical axis, we have to solve this for the price. We have to solve this function for the price. In other words, we're gonna have the 2PC. Let me just change the color here for a second. We're gonna have minus 2PC brought to the left-hand side and QD brought to the right-hand side. So that would become 2PC equal 15 minus QD. Now divide everything by 2, then price of copper would be equal to 7.5 minus 0.5 QD. Now, these two, of course, are basically the same thing. It's just one of them shows the quantity demanded as a function of price. The other one shows price as a function of quantity demanded. They are basically the same thing. So, if you want to graph this, you say, for example, if quantity demanded is 0, here in this function, if quantity demanded is 0, price would be 7.5, let's assume it is here. And then you can take the other extreme, since it is linear, you can take the other extreme. You would say, if price is 0, how much is quantity demanded? And you come up here, if price is 0, quantity demanded would be 15. Let's say 15 is here. And you connect the 2 points together, this would be the demand between 7.5 and 15. Okay? Now we will continue with the supply function. Again, we assume that supply of copper is a function of, in other words, quantity supply of copper is a function of several variables. Of course, the four most important is price of copper, and then we have wages or a wage index and a technology index, and also number of active mines. So again, 4 variables on the right-hand side, 4 independent variables on the right-hand side, and dependent variable, which is quantity supplied, on the left-hand side. Again, if we do multiple regression, collect the data for all these 5 variables: supply, quantity supplied, price of copper, wage index, technology index, and the number number of active mines, plug it into Excel or any statistical value, it would spit out the coefficients for us. And it would be something like this. This is according to the book again. QS equal minus 5 plus 8 PC minus 0.5 W plus 0.4 T plus 0.5 N. Again, these coefficients indicate the magnitude and the strength of each variable as it relates to the dependent variable QS. So if you have a plus 8 here for the PC, that means if price of copper goes up by 1 unit, quantity supply will go up by 8 units. Here, if wage index go up by 1 unit, quantity supply will go down by half a unit. And same thing with the technology, relationship will be 0.4 and 0.5 here. Now again, to be able to graph this on the two-dimensional plane, we have to assume all the variables except for price of copper remain constant. So we give you the value for W. Let's say W is equal to 100. That is the wage index, and technology index equal 50, and number of mines equal 20. So we plug in these numbers for W, for T, and for N. So again, QS this time, QS would be equal to minus 5 plus 8 PC minus 0.5 minus 0.5 times W. W is 100 plus 0.4 times T, which is 50, plus 0.5 times N, which is 20. So QS equal minus 5 plus 8 PC. Now 0.5 times 100 is minus 50 plus 0.4 times 50 is 20 plus 0.5 times 20 is 10. Therefore QS equal 10 and 20 is 30. 30 minus 50 is minus 20. Minus 20 and minus 5 is minus 25 plus 8 PC. Now this is the quantity supplied as a function of price of copper. Again, since we want to do this on the two-dimensional plane where Q is on the horizontal axis, P is on the vertical axis, we have to rewrite this as P equal QS. So we say 8 PC equals QS plus 25. Now if we divide everything by 8, that means PC equals 1/8 QS plus 25/8. So if quantity, for example, is at 0, if quantity is at 0, here price of copper would be 25/8. 25/8 is about 3, a little bit more than 3. So let's change the color here. Let's say it is about here. This is 25/8. That's 1 point. And we can find another point and connect it to the right hand side. Let's say that let's go back up here because they are the same function. Let's assume that the price of copper is equal to 10, for example. Price of copper is equal to 10. So if you plug in 10 here for price of copper, 10 times 8 is 80. 80 subtract 25 from it is what is 55. So 55 unit for Q, and at the price of 10. So if price is 10 up here, 55, let's assume this is 55. So when you connect these 2 points together, you get the supply. Okay? Now if you put this supply function with the demand function that you found here, this demand and this supply here, you put it together, then you would find the intersection of the two, which would give you the equilibrium price and equilibrium quantity. Mathematically, what you do is the two functions, again, I'm going to write it, one of them, the QD equal, what did we get, 15 minus 2 PC, yes, and the other one, QS equals minus 25 plus 8 PC. Right? At the equilibrium, QD should be equal to QS. So the left-hand side would be equal to each other. If the left-hand side are equal to each other, that means the right-hand side are also equal. So 15 minus 2 PC should be equal to minus 25 plus 8 PC. Take all the PC to one side, so this minus 2 would come to the right-hand side, would be plus 2 PC plus 8 PC. And take the 25 to the other side, it would become positive. So you would have 10 PC equal 40. Therefore, PC would be equal to 4. Price of copper equal to 4. Plug it back into one of the equations, either demand or supply, and you get this is equilibrium quantity. Equilibrium price. You plug it back into one of the functions, either the demand or the supply functions. Let's see, the demand function was QD equal 15 minus 2 PC. So plug in for PC4, Q would be equal to 15 minus 2 times 4, which is Q equal 7. This is, again, let's call this equilibrium. This is equilibrium quantity. Okay? So price would be $4 and quantity would be 7 units. This was a numerical example. Again, it was already in the chapter, and there are problems at the end of the book. The even number problems will have the answer in the back, so you can look at them and look at the answer in the back. And it's just simple algebra you need to solve.